In this next unit, we're going to look at a whole bunch of other operations we can do with numbers. So we've done the big ones, the basics, the integers and BEDMAS and fractions. But we want to start adding some words in there sometimes. So today we're going to look at rates, fractions, decimals, and percents. They're really just different versions of each other and used for different purposes. We'll start with rates. A rate is just a comparison of numbers where the second term is always 1. It's a special fraction. Okay, for instance, you might see it in speed. That's kilometers per hour. You saw 60 kilometers per hour, you're going 60 kilometers every hour. Okay, pay. How much are you getting paid? Minimum wage, $16 an hour. Okay, per 1 hour. Cost. How much it costs per kilograms. The line, this line right here, means the word per, as I've been saying, but it also means divide. Okay. The units are important. Okay. Is it dollars per kilogram or kilograms per dollar? It means a total different thing. Kilometers per hour or hours per kilometer, very, very different from each other. And the nice thing about the units is they often tell us what order to divide in. Like literally here, you take your kilometers and divide by your hours, or how much you got paid and divide by your hours, and you'll figure out your rate. Okay, we'll try a couple of examples to get our brains warmed up here. Okay, we have 2 different grocery stores, and granola bars are being sold at both. What is the difference in cost per granola bars at each of these 2 stores? Okay, as we look at the first one, it tells us we want to find the cost per granola. So in other words, divide your cost, $7.44, by how much granola we're getting. So we're getting 12 bars. Okay, calculate for this one. I got 62 cents per bar. Okay, second one, they sell it slightly differently. They have boxes of 5 granola bars, and it's 2 boxes for $6. So we got to get 2 boxes. It's going to cost us $12. But for that, we get 10 bars. So this one's $1.20 per bar. Okay. Obviously, the second one's more expensive. By how much? Let's take our $1.20 and we'll subtract our 62 cents. And we're left with 58. Okay, the question was, what is the difference? There is a difference of 58 cents per bar. Okay. One more question. Another one for you guys. You guys can try this one. Pause it, try it, see what you get. We got Janice and Irene buying apples at different stores. Both stores sell apples by the kilogram. Janice paid $6 for 375. Irene paid $5.25 for 3 kilograms. How much more will Irene pay than Janice if they'd each bought 9? So I can figure out how much it costs per kilogram. Take my 6, divide by my 375. Okay. The reason I'm doing this is it's easy to compare things when they're in the same units. So on this one, I got $1.60 a kilogram. Okay. If we go look at Irene, she paid $5.25. She got 3 kilograms. It works out to $1.75 a kilogram. And so she's paying, so messy 6 there, sorry guys. She's paying 15 cents more per kilogram. Right, 175 minus 160 is 15 cents. Again, 15 cents more per kilogram. So she bought 9 kilograms. I need 9 of these. So 9 times 15 cents is $1.35. Okay, and that's one way of doing it. You could have done different orders of things. You could have figured out this times 9 and this times 9 and then subtracted them. That would also work, but it doesn't really make a difference. Irene paid $1.35 more than Janice. Okay, those are rates. Okay, it's a really good use of a fraction. It's a per one. Okay, other ones we usually see. Decimals, fractions, percents, just interchangeable versions of each other. Okay, we've seen all these before, just some quick reminders of things. So how do you turn a fraction into a decimal? Literally divide. Okay, for instance, 2 divided by 5, that's what that means in the middle there, right? Is 0.4. Decimal to a percent, times it by 100. Okay? 0.32 is technically over 1. We want to make it over 100. On day 1 of numbers, we talked about that. Move it 2 spots, put on 2 zeros. Okay, so we can times it by 100 or just move your 2 spots. It works just as well. Okay, and then percent back to fraction. Well, 32 out of 100 is 32%, which is technically over 100, which you just showed, right? Okay. If you can, we want to reduce these, make your life easier. So a button on your calculator you probably have that you've never used before. It's called the fraction button. It might look like this one. Mine is literally a fraction. Other people have one that looks like A, B, C. It looks like a fraction button. It's a really handy button we're going to want to learn how to use. It helps us reduce things. Okay, 32 over 100. Reduce it 8/25. And we prefer a reduced fraction every time. Okay, you guys try the rest of the table. Convert 0.4 times by 100, you get 40%. As a fraction, we got 2/5. 87, that's 87 out of 100. Can't reduce that one. Divide it, you get 0.87. 0.08, that's 8%, which is 8 out of 100. That one we can reduce. Divide them both by 4 and you'll get 2/25, or use your fraction button. And 62%, that's out of 100. Reduce that one, it's 31 out of 50, or 0.62. Again, just another reminder, you can also divide this by 100. And if you want to go decimal to fraction, we learned how to do that on day 1. Start moving the decimal spot. All right, 0.62 over 1. And it becomes 62, 2 zeros. Okay, what else can we do with percents? Let's do some thinking questions, some word problems, if you will. 15 out of 25 students in Miss Waters' class earned an A on their final exam. Mr. Wong's class, 8 out of 20 earned an A. Which teacher awarded a higher percentage of A's? Like rates, it's easier to compare when they're the same kinds of things. And really, percent is just a special rate. Okay, 15 out of 25, that's a decimal. We can turn, or at least we can turn it into a decimal. And just grab your calculator there. I got 0.6 times it by 100, and that gives me 60% of the students in her class. Okay, on the other class, 8 out of 20, as a decimal, that is 0.4 times it by 100, and that's 40%. Okay, so which one had more A's? Miss Waters. A higher percentage. She gave it a higher rate of A's. Okay, another big thing we do with percents. Okay, we use the word percent of, which is technically a unit rate. 20% of 50. Well, percent of means I want to figure out 20 out of 100. Well, 20 out of 100 is 0.2. I want that portion of 50. Okay. This is per 1. I want per 50, so I times it by 50. Right. We get 10. Now to skip all that, not the ideas, not the thinking, but the math, the word of in math means multiply. So change your percent to a decimal and times it by the portion you want. It does all that stuff for you, just does it in one stage. And if we try the next one, 15% as a decimal times 60, we get 9. 107% as a decimal is 0.10 or 1.07 times 85 would give you 90.95. I hope it makes sense that this number is bigger than the 85 because we had more than 100%. It's as if you got some bonus marks on your test. Okay. Where we see this is often in thinking questions, word problems, sales, discounts, taxes. Percents are used all the time in the real world. Let's try a couple real quick here. We got Cornerstone High School. They have 1,860 students. 45% of them will bike or walk to school. So what this is really saying is, I want 45% of the 1860. Well, that's just 0.45 times 1860. I got 837 students bike or walk. We'll try another one with some money involved here. We got Terry bought some new skates on sale at 15% off the regular price. Regular price was $149.50. What was the sale price? Okay, so 15% of 149.5. That's really what we're being asked. So 0.15 times 149.5 is 2243. Now be careful, this is percent off the price. So our actual price was 149.50, and we get to take this amount off, leaving us with 127.07. Now this is totally fine, it works great. There's a faster way, just to point out to us. Okay. I prefer the faster way, and I'm going to use that. If something is 15% off, that means you actually pay not all of 100%, take off your 15%, and you pay 85% of the original price. So it allows me to do my calculation a little bit faster. If I take 0.85 times my 149.50, this is telling me how much I still have to pay of the original price. I get the same answer, just a lot faster. Okay? So taking the subtracting that we did second stage and doing it first. The reason you do it first is you could probably do that part in your head, and it just makes your life a little bit easier. Same math, just operational order is different. I got one last for us. The one, or do I have two? Let's see. Oh, I got two. Okay. You gotta be careful when you're applying percentages that you do it in stages. Okay. The example I like to use here is you walk into a store and it says something's 50% off. Let's say it was $100, but it's 50% off. Well, now you're paying $50, right? And there's an additional 50% off. That doesn't mean that it's now free, because you're not taking the 50 and the 50 and saying, oh, I get it all off the 100 and it's free. It's 50% off that new price. It's off of this. You have to do it in stages. Okay? You still have to pay $25. Well, taking a look at an example of how it works, we got the cost price of a video game for a retailer was $15.50. She marked it up by 30% to make some profit. What was the new selling price? So we used to have to pay 100% of the price, but if we mark it up, it's going up 30%. Now we're paying 130% of the price. The price was $15.50, okay, but I want 130% of the price. So as a decimal, that's 1.3. Okay, markups make things go up in price. So if you do that with your calculator, you should get 2015, I think. Okay. That's the new selling price. Okay. With 13% tax, what would it actually cost to buy? So again, you got to pay 100% of your price plus 13% more. That's taxes. So you're paying 113% of the price. Well, our price is now this much. So if I increase it by 13%, you should get $22.77 with tax. Okay. But notice you can't just add the 30 and add the 13 to 143%. It's not the same thing. Do it in stages. Okay, last one, you guys can try this one. Pause it, try it, see if you get the right answer. We got Jeff who bought a tennis racket for $98. It was 25% off, which means he's paying 75% of the price. So I'm going to do 0.75 times 98. And you got to take 25% off. It's $73.50. And having a sidewalk sale and offers an additional 10% off. So they're paying 90% of the price now. And again, the price has changed at $73.50. So 0.9 times $73.50 is, I got $66.15. Okay. If HST is charged at 13%, you're having to pay 113% of what he actually was buying it for, which was the sidewalk price. So 1.13 times 66.15. I got 74.75 as the actual price, or actual cost, I guess, not price. Okay, again, I did the fast way. You could do the slow way too, where you subtract each discount and do it in stages, but this is faster to do your subtracting in your head right off the top. Okay, there's a sheet to try. Give it a try. If you have questions, come see me, send me questions, and I can help you through it. Make sure you check your answers. Point out, always check your answers.